All right, let's get into it. You and I, we use apps all day, every day. But have you ever stopped to think about the incredible, invisible journey that software takes just to land on your screen? Well, that's what we're doing today, pulling back the curtain to see how it all really happens. I mean, seriously, think about it. 1 minute, your favorite app is one way, and the next, boom, there's a new feature. And the best part? You didn't feel a thing. It was completely seamless. That's not magic, my friends. That is some seriously clever engineering. So here's our roadmap. We're going to follow an app's journey in 4 big steps. First up, we'll look at the blueprint, the actual plan. Then, we figure out where the app is going to live. After that, we dive into the modern playbooks for getting it there. And finally, we'll see what it takes to keep it all running smoothly long after the big launch. You know, every great piece of software starts with a plan. You can think of it like planning a city. You wouldn't just start laying down bricks and pavement randomly, right? Of course not. You need a detailed blueprint that maps out the roads, the power grid, and how everything is going to connect and grow over time. See, most modern apps aren't built as one giant, single piece of code anymore. That's the old way. Today, it's all about something called microservices. The idea is simple. You break the application down into a bunch of smaller, independent services that just talk to each other. This is the secret sauce that makes apps so flexible and able to handle millions of users. So, when you're planning this city, you have to worry about a few key things. The network topology, that's your road system, making sure data can flow without causing massive traffic jams. Fault tolerance, that's like having a backup power generator. If one part of the city loses power, the whole place doesn't go dark. Data management is like the city's super secure vault, where all the important documents are kept safe. And monitoring? That's the dashboard in your car, warning you about problems before you break down on the side of the road. Okay, blueprint's done. Now for the next huge question. Where is this digital city actually going to be built? And trust me, this decision changes everything. The cost, the performance, how you manage the whole shebang. So really, it boils down to a massive trade-off. On-premises means you buy, own, and manage all of your own servers. You get total control, which is awesome for security, but man, it costs a ton upfront and it's not very flexible. Then you've got the cloud. You're basically renting server space from giants like Amazon or Google. It's way more flexible, you can scale up or down in seconds, and you only pay for what you use. The catch? You give up a little bit of that control. But of course, it doesn't have to be one or the other. A lot of companies go for a hybrid model. This is where they get clever. They'll keep the super sensitive stuff like customer data on their own secure servers, but then use the cloud's flexibility for everything else. It's a really popular strategy that tries to give you the best of both worlds. So, we've got our plan and we've picked a location. Now, how do we actually move the app into its new home? And maybe more importantly, how do we update it later without breaking everything for our users? This is where the deployment playbooks come in. The old school way of doing this was called Waterfall. It was slow, it was rigid, kind of like an old factory assembly line. You couldn't move to step 2 until step 1 was absolutely perfect. The modern world, it runs on Agile. It's all about being nimble, working in small bursts, and pushing out frequent updates. It's a mindset that actually welcomes change instead of running from it. And here is a fantastic example of an Agile playbook in action, the blue-green deployment. Imagine you have 2 identical versions of your app running at the same time. The one everyone is using is blue. You get your new update ready and deploy it to the green version, which nobody can see yet. You test it, make sure it's perfect, and then you just flip a switch. Instantly, all the users are sent to the new green version. The old blue one just sits there as a backup in case anything goes wrong. This is how you get those flawless updates with literally 0 downtime. And there are other clever strategies too, all focused on minimizing risk. A canary deployment is kind of like the old canary in a coal mine. You release the new update to just a tiny fraction of your users first. If they're happy, you roll it out to everyone else. A rolling deployment is similar. You just update your servers one by one, gradually introducing the new version. And the app is live. We did it. But hold on, because this journey is far from over. In fact, you could argue the hardest part is just beginning. Now you have to keep this thing running perfectly, securely, and reliably for potentially millions of people 24/7. All of this nonstop work is powered by a huge cultural shift called DevOps. See, back in the day, the people who built the software, the developers, and the people who ran the software, the operations team, were in completely different worlds. They often didn't get along.
DevOps tears down those walls. It's all about collaboration and automation to make the whole process faster, better, and more efficient. Now, if DevOps is the philosophy, then site reliability engineering, or SRE, is the intense, hardcore practice that brings it to life. SREs are engineers who look at operations problems, like a server crashing, and treat them like software bugs. They build automated systems to solve those problems so they never happen again. Okay, now this is where things get really wild. This idea sounds completely nuts at first, but it's pure genius. Netflix created a tool they called Chaos Monkey. And what does it do? It intentionally and randomly shuts down parts of their live system on purpose. Why would they do that? To force their engineers to build a system so strong that it can survive completely random, unexpected failures. And it's not just Netflix. This idea of controlled chaos has become a whole engineering discipline. There are all these tools designed to break things in different ways. The philosophy is simple but powerful. The only way to be sure your system is strong is to constantly try and break it yourself. So while all this chaos testing is happening, teams are also constantly on guard. They're monitoring performance to spot slowdowns, they're watching for security threats, they're always pushing out regular updates, and, this is a big one, they're planning for disasters. The work truly never, ever ends. So I want to leave you with this thought. The absolute cutting edge of building reliable software isn't about preventing failure at all costs. It's about embracing failure, learning from it, and using it to get stronger. It makes you wonder, right? If true resilience comes from being designed to handle chaos, what does that say about how we should be building, well, anything for the future?